Okay. So, in this puzzle Tower of Hanoi, it is a mathematical puzzle. It consists of 3 rods or towers and a number of discs of different sizes are given, right. So, I will start with an example, then I will come to the rules here, right. So, there is a kind of a rods like this, no, a pole is there on a structure like this, right, and you are given some 3 plates. Okay, some plates, or you may think as a plate or no disc, right, CD disc we put on some top, right. Like this you have 3 towers, okay, 3 towers, and there are discs of different size. There are discs of different size. Okay, so what is the size? Let's take one disc is of size 3, other disc is of size 2, another disc is of size 1. Okay, right, there are 3 discs. Now, this is your source, this should be a destination, this is your temporary, this is your temporary. You have to move the disk from source to destination in the same order like this. But the condition is that you can take help of temporary tower, you can use of temporary rod. The condition is that always the lower one should be on top of the upper one. So, I cannot have one here and on top 3 like this, this is wrong. Always the smallest one should be on top of the larger one. Okay. So, you cannot have no the different. Suppose let's see the logic, how do I shift. Okay, let's assume given only number of disk is 2. Okay, given the number of disk is 2, it means there is a disk of size 2, then there is a disk of size 1. I want to move them to destination. What will I do? It is quite common that you will move this disk number 1 from here to the temp, disk number 1. So, from the source you have moved it to temp. The disk number 1 you have moved from source to temp. After that, this is gone now. This is gone. Next, what will you do? You will move this 2 from source to destination directly. So, next step is source to destination. So, this 2 is gone and we got it here, the 2. Then the third step is to move the disk from temporary to the destination 1 like this. So, it is from temporary to destination. So, these 3 steps we take to shift the disk from source to the destination. If the number of rods is 2, right? If the number of rods is 2, within 3 steps we can move the disk from S to D. Okay. Now, let us do another example here. Assume the number of disk given to us is 3. Assume the number of disk given to us is N is 3. So, I have in source 3, then I have 2, then I have 1. How will we move? What should be our steps? Right? Can you guess how can I move? Can you tell those 8 steps how to move such that I get all this disk into destination in the same format? Take pen and paper and try to solve. Okay, maybe let me solve this for 1, for n equal 3, n equal 4, you try and tell. So, first step is to move this one from the source to the destination, put it 1 here. Okay, so first step, source to the destination. Second step, from source to the temporary. So, 2 has come here, from source to the temporary. Then third step, from D to this temporary 1. So, from D to the temporary. Next step, move this 3. We want our 3 plate to be here in D, right? So, move this 3 from here to directly to the D. Okay. So, it is from S to D. Next what I have to do? From temp move this 1 to S. Move this 1 to S like this. So, it is from temp to S. Now, move this temp, move the disk in temp to D. So, this 2 will go away and come here as 2. So, that is what? From temp to D. Then the final step, from the S you bring that to here. You bring that to here onto the disk. That is from S to D. Right? This is what we are trying to do here. Right? From source to the destination. If I write them here, you see S to D, S to T, D to T, and then S to D, then again T to S, T to D and S to D. Okay. So, if you observe the middle one is from source to destination directly. Even in that two disks, when there were two disks, the middle step was directly from source to the destination. Remaining we are using the the ones which we want accordingly, right. So, this way we are trying to shift. Now, so how many steps are there when n is 7? Number of steps is 7. Okay. Now, you predict, given the number of disks is 4, given the number of disks is 4, how many steps we will require and what are those steps. Okay. Very important and interesting problem. Please try this, take pen and paper and try to solve this, how we move the disks from source to destination if the number of plates are 4. Given the number of plates are 4, how many steps we need and what are those steps? Please try. Let us analyze the solution. If the n value is 4, you have 4 here, 4, then 3, then 2 and then 1, right. First obviously I will move this 1, 1 will come here, then 2 will come here, right. So, from source to the destination first, then source to the temporary, right. Then you will bring this 1 back here. So, that is from destination to temporary. So, here 1, 2 has gone. Now, you will take away this 3, take away this 3 from source to the destination. Source to the destination, 3 comes here. So, 3 is deleted. Then you take this 1 and you try to put that 1 here, right. So, it is from temp to destination. Then take away this 2 and place it here, then take away this 1 and place it here, then this 3 will come here, sorry, this will be our 3, right. Again you will take this 1 and place it in D, then take this 2 and place it here, then bring this 1 to here, right. So, you completed certain steps, then the final one, that 4 goes here into the destination. Again from here you take 1 to this, 1 comes here, then you take this 2 to here, right. Then you will take this, oh no, we missed somewhere here, it was 2 and 1, right. So, after this I will take this 1 from temporary to this 4, then I will take this 2 to here, then I will bring this 1 from destination to here. Now, it is very easy for me to shift this 3 from here to 3. Now, it is simple, bring this 1 to here, then take this 2 here, then bring this 1 here. So, this way you can shift it, right. But there is some hidden pattern in this process. Okay. There is some hidden pattern in this process which we have to identify. What is that process which we have to identify? Okay, let us do the analysis. What is the hidden pattern? How can we write the logic for this recursive logic for this? Okay, how do we write the recursive logic for this? See, if you observe the pattern here, let us do it for, let us write those steps. Right. So, your this maybe again here the logic is different, but you have to think about the what could be our source, destination and the temporary. Okay. So, we have 3 things: source, temporary and destination, right. From where are you shifting, using which help, using whose help are you shifting those elements, that you have to take care. So, let us see the analysis how we try to do. Let us take 2 steps only. Okay. So, from source I am shifting, my source is actually, what is my destination here? Destination is T, okay, destination is my T. Why? Because 1 I am bringing here, 1 I am bringing here, okay, this is my source, this is my destination, this is my temporary, okay. So, here we are not using anything here, we are moving 1 from source to this location, okay. Next you are moving this 2 from source to destination. So S to D. Okay. Next, I am not using any temporary here, just moving. Then you are moving from temporary to destination, from here to here. No, sorry, 1. Right. So we are moving between, it is from source to destination. The middle one, it is source to destination. The upper half you see, it is from source to temporary. The lower half you see, it is from temporary to destination. I am just trying to make an analysis here. Out of 3 steps, the middle step is to source to destination directly. But before the upper half, you see, it is from source to temporary. The lower half is, if you see, it is from temporary to destination. Now this is the case for number of elements is 3. Number of elements is 2. Now let us make analysis for other case. Let me delete all this. Yeah, this is my temp, this is my destination, and this is our source. So assume we have 3, 2 and 1. Okay. So I have 3 parameters here: source, destination and temporary. These are fixed. Source, destination and temporary are fixed. So what is my first step? First step is source, this one I am taking from source to destination. So I am doing from source to destination. So 1 is coming here, 1. So 1 is gone. Next it is from source to temporary. It is from source to temporary. So this 2 I am taking away and putting it here. Then again you are moving from destination to temporary. This 1 is moving from here. Okay. So I am taking help of temp here, I am taking help of destination, I am taking help of source. The remaining things I am just filling there. Next, after 3 steps, I am taking this largest one to destination, that is from source to destination. This is the middle step. Next, now what is your SDT? Continuation of that. Now from temp to source you are putting, from 1 you are putting it here. Then temp to D you are putting. So you are taking away this here. Then again source to D. So if you see, the middle step is from source to destination. The above steps I am moving from either of the thing, I am moving to temporary, and from temporary I am moving it to destination. Right. So we are doing this way. So sometimes this is your source, sometimes this is your source, and sometimes this is your source. Right. So with this, if you see the algorithm here, move top n minus 1 disks. Okay. If there are n is equal to 2, we have seen that move top n minus 1 means first disk. Move that disk from source to temporary. Then move the nth disk from source to destination, that is the second disk, the actual one, you move from source to the destination. Then move the n minus 1 disk from temporary to destination. This one which is in temporary, you move it to destination. That is what the algorithm we are following here. Right. So first n minus 1, let us take n is equal to 3. N is equal to 3. What is our goal? Our goal here, it is 3, then 2, then 1. This is my temp and this is my destination. After certain steps, what I am trying to do, taking this 1 here, then bringing this 2 here, then bringing back this 1 here. 3 steps. See, n minus 1 means 2. Move top 2 disks from source to destination. I have moved, no? From source to temporary, I have moved them, this 2, 1 here. Then move the nth disk, that is the third disk, from source to destination. This 3 is coming directly into the destination. Then move the n minus 1 disk from auxiliary to destination. Move these two disks from this temporary to the destination. That is what the algorithm is. Right. So source, so the steps is very clear. So n minus 1 disks, okay, you have to move this n minus 1 disk from source to temporary using the destination. Then move the n disks from source to destination using temporary. Then remaining n minus 1, you move it from temporary to destination using source. I hope you understood, right? Move n minus 1 disk from source to temporary using help of the destination. Then the middle step, move the nth disk from source to destination using temporary. The last disk, move the n minus 1 disk, remaining n minus disk or the number of n minus 1 disk from temporary to destination using source. So this is the logic here, right? So middle step is one time activity. Middle step is one time activity. Why it is one time activity? We are just to move from source to destination. That's it. We are not using any temporary, and that to one disk only. So we are not highlighting it, right? So if you observe, it is n minus 1 number of disk from source to destination using from source to temporary using destination. Then simply move from source to destination. Then the third step, move those n minus 1 from temporary to destination using source. So these parameters you have to give to the function. Okay, let's see the recursive implementation of this Tower of Hanoi, right? See, Tower of Hanoi, I am giving the n, I am giving the source, I am giving the destination, I am giving the temp as the parameters, right? So this is my base case. We will leave this base case now. See, first step, take n minus 1 disk from source, move it to temporary using destination. See, n minus 1 from source to temporary using destination. Then after that, move from source to destination directly. Move from source to destination directly. After that, again same function Tower of Hanoi I am calling it. Yeah, remaining n minus 1, move from temporary to destination using source. Using the source, right? So I am calling this function recursively. This is the logic for finding out number of how many number of disks or how many number of moves. This will help us in doing that. See, what is the exit case? If n becomes 1, move disk 1 from source to destination directly. If there is only one item, move it directly from source to destination, right? So if you give like this n, a, c, b, it will move from A to C using help of B. You tell number of disks. So it will give all the steps of moving the disk from n from source to destination, right? It will give the steps. This algorithm will give you the steps to move from one source to destination, right? This is how we use recursion. Okay, n minus 1, the source, the destination and the temporary. Here also n minus 1, the source, the destination and the temporary. Logic is same, right? So this is about the Tower of Hanoi puzzle, how we try to do that using recursion, right? Interesting problem. You have to solve this. Sometimes even they ask you if there are 4 plates, if there are 5 plates, so what will be the number of steps? Number of steps is easy, but they will ask you after certain after 10 movements. After 10 movements, okay, where is the plate number? Plate number 3. Where it is there? Is it in source or is it in destination or is it in temporary? These kind of questions are framed on this Tower of Hanoi problem, right?